Today in class we learned a lot of things about some basic geometry concepts, a bunch of definitions, we saw some symbols. All of that should be in your notes. If you were absent today, you're going to need to come and copy a whole bunch of notes from me because that's going to be the basis of a lot of what we're going to talk about this week. I'd kind of like to actually finish that lesson by covering the rest of the basic geometry stuff that we need to know for this week and for most of what we'll need for the rest of this year. One other concept that we did not talk about today in class was that of exterior angles. So first of all, I'm going to draw a triangle. This could be any triangle, it doesn't matter what the angle sizes are. But if I continue to draw one side out here, and suppose that that was a straight line, this right here is a straight line, then what I've got is the three interior angles to the triangle, and I'll number those. Let's just call them angle 1, 2, and 3 like this. Then this angle out here that's exterior to the angle, that's outside the triangle, is called the exterior angle. And since it was formed by a straight line with the bottom of this triangle, then 3 and 4 are supposed to be supplementary to each other. And they would have to be. So the measure of angle 3 plus the measure of angle 4 is 180 degrees because those together would be supplementary, making a straight line. So that straight angle there is going to get us a start point for the fact that we could also say the triangle sum theorem here tells me that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is also equal to 180 degrees. Now notice that I've got an angle 3 in both of these equations here, which means that if I subtract measure of angle 3 from both sides, I don't know what that is, but if I subtract that from both sides, I would be left with just measure of angle 4 here on this side and the measure of angles 1 and 2. And since in these equations they're both equal to 180 degrees, that must mean that they're equal to each other. For simplicity's sake, I'm going to stop writing measure and angle. I'm just going to use the number of the angle. And so I'm going to have something that looks like this. So here's just a smaller version, so I've got more room to write. But angle 1 plus angle 2 plus angle 3 is all equal to 180 degrees, and angle 3 plus angle 4 is also equal to 180 degrees, for different reasons. Now, since they're both equal to 180 degrees, that means that those would be equal to each other. So angle 1 plus angle 2 plus angle 3 is equal to angle 3 plus angle 4. Both of these expressions equaling 180 degrees, so they must be equal to each other. If I subtract the measure of angle 3 from both sides, then I'm left with the measure of angle 1 plus 2 must be equal to the measure of angle 4. This is called the exterior Angles theorem. And just tells us that any exterior angle, which again that exterior angle must be one that forms a straight line with one of the sides of the triangle. But any exterior angle is equal to the sum of the angles opposite it. Not the one that's right there adjacent to it, but the angles that are opposite angle 4. So together 1 and 2 must always add to whatever that exterior angle is. The definition for similar polygons is that all of the corresponding angles need to be congruent and all of the corresponding sides need to be proportional. This example in this image here is using right triangles to say that these are similar if their corresponding leg lengths are proportional. That is a more specific case of the definition of similar polygons because it's a right triangle as opposed to just any kind of polygon. But this is the kind that we will be using in this class to demonstrate something later this week. Triangle ABC is similar to triangle DEF if the ratio of the leg AB here is to the ratio of leg DE, so the two red parts, the lengths of those legs, is the same ratio as whatever the length of AC is to DF here. And so that would define that as similar right triangles. Here's an example. We're supposed to tell whether these right triangles are similar. The way that we'll do that again is we will set up the ratios of the corresponding sides. So it looks like side M or NP and KL are corresponding sides. They're both oriented the same way. The triangles are oriented the same way. And we know that they're both right triangles. So the right side, I can call it the right leg, I guess, is we're going to check out and see if KL over NP, is it really the same ratio as the other side? And I'll just use red for that one. As JL is to MP. Okay, let's insert numbers into our equation and see if it all works out. So going back to green, KL is 7.5 and NP is 5. And we're checking to see, does that really equal, I'm going back to red now, JL is 12 and MP is 8. Is that the same ratio? Well, both of these, I could do one of two methods. I could cross multiply and see if the cross products are the same, or I could reduce both fractions to a common ratio. And if we simplify this, or if I cross multiply, I'll find out that yes, it is proportional. The cross products in this case, 5 times 12 would be 60, and so would 7.5 times 8 also be 60. Since those values are the same, it shows that the ratios are equal to each other. Or I could just reduce both of these. This is 3 times 4, and that's 2 times 4. And so this would reduce the 4's, leaving me with 3 over 2, showing me that those ratios are equal, so those must be similar triangles. One last test to tell if two triangles are similar to each other is if two of the angles are congruent, that's enough to know that the triangles themselves are congruent. And they don't even have to be right triangles. But my example here has right triangles, and I know that right angles are congruent to each other because they both equal 90 degrees. But what about either M and J or else N and K? Well, I've got this set up so that I can actually overlay this, and we can see that M and J actually are congruent angles. I could do it this way as well, and show that K and N are also. But because of the triangle sum theorem, we would know that that third one would have to be. This right there is enough information. Two angles being congruent is enough information to tell me that those triangles have to be similar to each other. I think that's where I'm going to stop the video lesson. Give you a couple of problems to work out so that you'll have something for the warm-ups for tomorrow. But all of these concepts need to be something that you understand and can use as justification or explanation for something that we're trying to convince ourselves of in class. Here are two problems for you to try. These will be the you'll transfer these answers to your warm-ups for tomorrow. Good luck.